Hey everyone, so today's Saturday and time for an impromptu video. I want to talk about how AI agent development is nothing like traditional software development, and this has been experience past in building multiple agents, both professionally and personally. And I've been thinking about how when we are building these AI agents, how the whole traditional software development mindset falls flat. And that's the reason why a lot of application layer agents or the companies that are building it is simply just API calls to LLMs and putting them in traditional software mode. So let's talk about how the agent development is very different. When we think of a software, we think about platforms, right? Web platform, app platform, and now LLM as a platform. We started with web, and whenever we think about the software, we think about different aspects of it, use cases that you can build, architecture, UX and workflows for your users, who are the users, stability, performance, these are the aspects. And I'm going to talk about why all of these aspects completely fall flat and are very, very different from what traditional software used to be. So if you look at the web as a platform, it started with the web. It was easily accessible to everyone via a browser. The use cases, a lot of use cases came, e-commerce and so on, came because it was accessible to a lot of users using the browsers on their personal computing and so on. And it was built mostly for humans, navigation and so on. The architecture obviously was typical traditional software architecture. There's front end, back end, APIs flowing around. The UX and workflows are majorly focused on how do we make sure that humans navigate the task that they're doing on the web in the most efficient way that is possible, and presenting information in the right form and so on. Stability, performance, again, how it worked. Stability and software stabilities make sure that the all the features and everything are functioning fine, uptime and so on. Latency, again, it all depends on how fast humans can navigate the whole application, web application, and just finish off their task. Then came the app platform paradigm. The platform shift happened. App was also very, very similar to web, except in some cases. So for example, the UX and workflows completely changed. So all these hamburger menu, tab based, your software being navigable on with one finger, all of these workflows came because the app ecosystem or mobile as a platform was very, very different. And people, and it led to a lot of different kind of use cases like Uber and so on. They were possible because you had a mobile platform on your hands always. Stability, performance kind of remained the same. The architecture remains the same, front end, back and so on. UX workflows, as I said, changed drastically. Some new kind of use cases always emerge when the platform shift happens. So now let's talk about the new platform that we are all building on top of, and that's called LLM as a platform, and what I call intelligence as a service. Very, very different from what web and app were. They were all OS and hard coded by sort of developers. Their intelligence was whatever the developer would encode into the OS and so on. In the case of LLM as a platform, the biggest shift that happens, or the LLM model, is that LLM model has intelligence baked in, and it can think and it can decide, and based on the tasks, it can break down tasks and do a lot of reasoning and thinking. That is a big, profound shift that has happened, and that leads to a lot of changes, because once you have thinking or intelligence as a service available in the form of an LLM, your only job remains is how do you provide the right kind of environment for them to flourish, which is exactly how humans work. Humans have brains, and we have different environments available to us, and we're allowed to be able to think and act in those environments. So let's look at these use cases, right? So let's think of the aspects that we were talking about and how do they work in a LLM as a platform era, which is what, if you look at the apps that you build on top of this LLM, is essentially what are called agents. The whole point of calling these apps instead of mobile apps or web apps, the whole point of calling these as agents was because this kind of an agent that you build on top of an LLM has agency. And till now only humans had agency, and this time now the software has agency to be able to think and act. This opens up a lot of use cases. You can do now literally real world tasks. When I say real world tasks, if you think of digitally, it's obviously programming which required thinking. Now the thinking is done by LLM, generating code and so on, or any kind of digital task, being able to do shopping or whatnot, and then it will percolate into real physical tasks also, because again we have intelligence of brain available and we just need an environment. So all kind of cases where there was agency required, you needed someone to think and being able to do, is where all these agents are coming up. This was not possible earlier because the software could not think. The earlier software, web apps or mobile app, was simply doing what was encoded in them by the developer. So the developer was doing the thinking. If you look at the users, all these LLM apps that we are building, in fact, most of the software that we are going to build is built for agents. It's not built for humans. The agents are going to operate that software. Humans are basically there for quality, review, supervision, and you'll see that increasingly happen in both digital and eventually in the physical world as well. Architecture. Again, we talk a lot about front end, back end, so on, traditional architecture, and we start talking about when we talk about LLMs, we talk about harness. And the reason why we don't call it an architecture harness, because the job of a LLM app or an agent is simply to harness the power of the underlying model in a well-defined environment for a well-defined task. So, and that's the reason why we call harness, and it's very interesting. We don't call it a traditional software architecture. And again, the job is to what kind of scaffolding we can give for LLMs to be able to go and be able to do a task in a very reliable manner. And that's why we call it a harness. UX and workflow, drastic change, very different from what traditional software. Traditional software UX workflows are built for humans. And that's why all the patterns and all the design and everything, philosophy, design systems were built for humans. Agents or LLM apps are built for agents, and agents don't like elaborate UI. Agents like CLIs and MCPs and tools and whatnot. And all these primitives, this is the UX and workflow language of an agent. The CLI tools being available, and that's why Cloud Code and every agent is like really valuable, because you can play around with all these tools. And that's how it's much easier for a LLM to be play around with a CLI tool or an MCP kind of a tools or markdown files and so on, instead of a UI. And that's why the whole UX and workflow collapses. Whereas it's not about just agent doing, you need humans for reviews, and that's why humans are more about review workflow. So a great example of it is Cursor, where they do the task and they share a video of the task of end of working. So that's like a totally different paradigm, where the agent is just literally doing some work in the cloud. And what's the best way for human to review? Probably they come up with videos, audio, and whatever is required for the human to review the task really well. So that's again, UX has completely drastically changed. When we talk about stability, again, the first time when you have intelligence, it is non-deterministic. And in many of the tasks, you can't even define what is good or bad. Coding, fortunately, is easy to define if it works or not. And that's the reason why coding agents are flourishing. But now the whole paradigm of evals comes, and your traditional stability still remains, but the biggest difficulty or the chunk of the work is going to be the evaluation, whether this is good enough. And that takes just enormous amount of work. And that what becomes important rather is, do you have the right data set? Do you have the labeled data set? Is your data set has the right set of characteristics of what your agent is going to see in the real world? So very different, not so much new for people who come from ML backgrounds or working with AI systems, but for anybody else, incredibly different mindset altogether. Latency or performance that we talk about. Again, the whole point of latency or performance was built in the older era of software, where if humans are seeing loader and they're able to not finish the task, they're waiting, the software is dumb, it simply just does what user does. User says, like click button, this and that. Obviously, the latency paradigm was different. When you build intelligence as a service, when you have thinking about intelligence or agency or agents, the whole paradigm of latency completely changes. Now you think about, if the agent is like really reliable, I will completely build an async task. Like I'll just fire off a cloud agent and it does the work, and I'm not even interested in looking at what it is doing and accept the final outcome or the review that I'm going to do. but many of the agents and many of the tasks are not there. So you think about synchronous workflows where I'm sitting and I am nudging or triggering this, steering the agent towards the direction that I want, and it takes multiple loops because no agent is going to give me output in the one single shot. And that's why the whole UI is moving around chat ecosystems and all that, because you can do back and forth or steer the agent. But it's also how much time an agent takes comes with what is the kind of task we are doing and what is the kind of quality that is expected. So if there is a task that I do literally 1 hour in a week, I would really want a better, higher quality from the agent versus some agent which does in 5 minutes. And that's the reason why you're seeing a lot of LLMs have this thinking mode, where small thinking, less thinking, high thinking, extra high thinking, X high, and so on. And the reason is because the more time you give LLMs to think, the time and the token, the better, the higher quality of the output it will be within some guardrails and so on. So the whole point of latency completely collapses, and you have to look at the kind of tasks that the agent is doing and what kind of intelligence or thinking does it require, what kind of quality that is expected. Do you expect human to be sitting and waiting for the outcome and nudging the agent, or is it so auto verifiable that you can do it in the cloud? And that's the way to think about latency. So if you look at it, a lot of LLM based apps that we build on top of it, or / quote unquote agents, our use cases are different, our use curves are different, our architecture is different, our UX and workflows are different, our stability is different, sol evals, and latency thought process is also different. I think this is what is missing in a lot of application layer products or agents that we are building, because we have not really realized that how much agent development is totally different from software development, traditional software development. And I think it's slowly and steadily the industry will realize, and we actually start working backwards from the power of models and what kind of agents that we can build or apps we can build on top of it, versus looking at it from a more traditional software mindset, and that we have an API and trying to stuff that API into some kind of a traditional software workflow. Yeah, thank you.